Okay guys, we're going to start talking about our next little section. I'm going to go ahead and say that this is section 5-2. We can actually, just like we separated before, um, let's say that we have an nth root, our index is n, and we have a and b. We have two different roots. We have the same index with two different radicands. We can actually combine them under the same radical sign, keeping the same index. And since we're multiplying, we can say that we have a times b. Here's a question. Can these roots be multiplied? Notice that it's not necessary that I put these two, but I'm just going to do it to show you what's there. And the answer, at this point, I would like you to think about what we've done, but the answer is no. And I'm getting the little spinny wheel. I'm not liking that much. No, because the indices are not equal. Now we know that the index 3 is not equal to the index 2 equal. So that would be a good example to show when two radicals can be multiplied. Let's go ahead and look at an example in which they can be combined. Okay, so let's say that I have the same question. I'm going to have to write a little bit smaller here. I want it green. Let's see, the cubic root of 27 8 be multiplied. Cubic root of 8. Can these be, and I forgot to write these on the top, can they be multiplied? Can these be multiplied? And in this case, the answer is yes, because yes, and it would look something like this. I would keep the radical sign with the same index and just multiply the radicands, which are the numbers inside. So 27 times 8 is 216. So we have the cubic root of 216, which, if you do a little bit of thinking, is 6. Now notice that there's another way to achieve this solution. If I ask myself what's the cubic root of 27, the answer is 3. If I ask myself what's the cubic root of 8, the answer is 2. And I'm running out of battery again. And we know that 3 times 2 is 6, which is the same answer that we got. cubic root of 54 x to the 5th. So in this case, we're going to use the same technique we used before. We're going to want to group these in groups of 3 so that they can come out of the radical. The same thing with the 54. And we're going to want to cancel out whatever we can find with the index. And let me show you what I mean by this. Let's first take a look at this 54. You want to ask yourself, how can you produce a cubic number, or a number raised to the cubic power, out of a 54? And what's going to allow us to do that is to actually list the factors of 54. So if you do your number tree, going back to elementary, you can say that you have 2 and 27. So the 2 is already a prime number. So we continue with 27 and we say that that's 3 times 9. And if we continue with the 9, we know that this is 3 times 3. So looking at the prime factorization of 54, we know that 54 is the same as 2 times 3 times 3 times 3, or 3 cubed. So that was easy once you use the number tree. So keeping that in mind, and I can go ahead and say that this radical becomes 2 times 3 cubed. That was an ugly 3. Let me try it again. 2 times 3 cubed. And the 5 is a little bit easier to break down, because you know that in a 5, in x to the 5th, we can actually just break it down into x to the 3rd times x squared. And if you have a problem understanding that part, please see me or send me a message. So now, what can we do with this? If we've done things correctly, I forgot to include the index. Sorry about that. This should be an index of 3 or a cubic root. So why is this index important? Because it's gonna tell us exactly which one of these numbers are gonna cancel out. Now, if we look at everybody inside the radical, I'm going to take a look at this guy because he has a power of 3. And I'm going to take a look at this guy because he has a power of 3. Because they have a power of 3, now they now have the ability, it's like they have the permission to go outside of the radical. But when they do, they go ahead and leave their exponent. So now I have a 3 outside and an x outside. Remember, it took a group of cubes to cancel out with the index. However, I also have some people inside, or a couple of terms inside that we're not allowed to leave. Specifically, I have these 2 that stayed inside, and let me be specific, it's a 2 to the 1st power. I keep forgetting this index. And then I have this x squared that wasn't allowed to leave. Why were they not allowed to leave? Because they fell short meeting the requirement to come out, which was this index. So because this is a 1 is 2 short, this 2 short, and this is 1x short, they stay inside. So your actual answer is 3x times the cubic root of 2x squared.